Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed question number 6 and 7 from the miscellaneous exercise. Hope it's clear for you all. In today's session, we shall discuss the remaining problems from the miscellaneous exercise. Let's move on to the topic. Now, let's discuss question number 8 from the miscellaneous exercise. A fruit grower can use two types of fertilizer in his garden, brand P and brand Q. The amounts in kilogram of nitrogen, phosphoric acid, potash and chlorine in a bag of each brand are given in the table. Tests indicate that the garden needs at least 240 kg of phosphoric acid, at least 270 kg of potash and at most 310 kg of chlorine. The grower wants to minimize the amount of nitrogen added to the garden. How many bags of each brand should be used? What is the minimum amount of nitrogen added in the garden? There is a table also given to you, kg per bag. Two brands are mentioned, brand P and brand Q. Nitrogen 3 and 3.5 kg per bag. Phosphoric acid 1 and 2 kg per bag. Potash 3 and 1.5 kg per bag. Chlorine 1.5 and 2 kg per bag. Let's go through the question again. A fruit grower can use two types of fertilizer in his garden. Two brand names are given, brand P and brand Q. And the amounts in kg of nitrogen, phosphoric acid, potash and chlorine in a bag of each brand are given in the table, that is here. Test results are also given. Tests indicate that the garden needs at least 240 kg of phosphoric acid. At least is the keyword, means greater than or equal to 240 kg. And here at least 270 kg of potash, means greater than or equal to, again at least is the keyword, greater than or equal to 270 kg. And at most 310 kg of chlorine, means at most is the keyword, less than or equal to. So maximum 310, so less than or equal to 310 kg. If the grower wants to minimize the amount of nitrogen added to the garden, that means we have to minimize this one, quantity of nitrogen 3 and 3.5. So this is the minimizing inequality or equation we have to make by using these values. And the remaining 3 we have to use for making the constraints. What we have to calculate is how many bags of each brand should be used. Question, if the grower wants to minimize the amount of nitrogen, that means how many bags of each brand should be used for minimizing the nitrogen. And what is the minimum amount of nitrogen added in the garden? The minimum amount also you have to calculate. So let's go for assumption. Let bags of brand P needed be X. X quantities of brand P we need, and Y bags of brand Q we need, and X and Y is assumed. X means bags of brand P needed and Y means bags of brand Q needed. Let's summarize the question here. So nitrogen we have to use for minimizing equation. So we have to use phosphoric acid, potash and chlorine. So these are the other 3 given conditions. So phosphoric acid, potash and chlorine. And phosphoric acid case, when you consider brand P is having 1 kg and brand Q is having 2 kg per bag. And in case of potash, 3 and 1.5, 3 kg and 1.5 kg. And in case of chlorine, brand P is having 1.5 kg and brand Q is having 2 kg. And the requirement, let's check. Requirement at least 240 kg of phosphoric acid, that is written. Next is at least 270 kg of potash, it's written here. And at most 300 kg of chlorine. So at most 310 kg, it's written here. Next, what we have to do is, by using these conditions, we have to make the inequalities. That means here 1 into X plus 2 into Y at least means greater than or equal to 240. So X plus 2Y greater than or equal to 240. The next one is 3 into X plus 1.5 into Y is at least means greater than or equal to 270. And the next one is 1.5 into X plus 2 into Y. Next keyword is at most, means less than or equal to 310. So 3 inequalities we have got. And there are two common constraints are there, that is x greater than or equal to 0 and y greater than or equal to 0. So there are 5 inequalities: first one, second one, third one, fourth one and fifth one. Function used is minimize z. So z is the function we are using. We have to minimize the amount of nitrogen. That means brand P contains 3 kg of nitrogen and brand Q contains 3.5 kg of nitrogen. That means we have to minimize z is equal to 3x plus 3.5 into y. So 3 into x bags of P and 3.5 into y bags of Q. That is z is equal to 3x plus 3.5 y. We have to minimize this equation. Next, let's summarize the minimizing equation and the constraints. We have to minimize z is equal to 3x plus 1.5 into y, and subject to constraints x plus 2y greater than or equal to 240, 3x plus 1.5y greater than or equal to 270, 1.5x plus 2y less than or equal to 310, x greater than or equal to 0, y greater than or equal to 0. So these inequalities we have to represent it in a graph sheet, and we have to shade the bounded region and find out the corner points, and by using that corner points we have to minimize by using this equation. So that portion you will do it as homework. Next, move on to question number 9. Refer to question number 8. If the grower wants to maximize the amount of nitrogen added to the garden, how many bags of each brand should be added? What is the maximum amount of nitrogen added? Here, the same question only, question number 8 only we have to consider, and previous question in question number 8 we have minimized the amount of nitrogen added to the garden, and the same graph and the same quantities we can use, and by using that we have to maximize the amount of nitrogen added to the garden. That means we have to choose the maximum value from the table, from the corner points table. We have to find out the maximum value and we have to write down the answer. Two questions are here: how many bags of each brand should be added and what is the maximum amount of nitrogen added. By using the previous graph we have to calculate this one. So this also you will try it as homework. Next we shall discuss question number 10. That is the last question from this chapter. A toy company manufactures two types of dolls, A and B. Marketers and available resources have indicated that the combined production level should not exceed 1,200 dolls per week, and the demand for dolls of type B is at most half of that for the dolls of type A. Further, the production level of dolls of type A can exceed 3 times the production of dolls of other type by at most 600 units. The company makes profits of rupees 12 and rupees 16 per doll respectively on dolls A and B. How many of each should be produced weekly in order to maximize the profit? Here, let's go through the question once again. A company manufactures two types of dolls, A and B. And there are some market tests they have conducted, and the results says that the combined production level should not exceed 1,200 dolls per week. Combined means number of toys of type A and number of toys of type B together should not exceed 1,200. And there are some other conditions. Demand for dolls of type B is at most half of that for dolls of type A. And further, the production level of dolls of type A can exceed 3 times the production of dolls of other type by at most 600 units. And if the company makes profit rupees 12 and rupees 16 per doll respectively on dolls A and B, how many of each should be produced weekly in order to maximize the profit? So how many of each should be produced? So we have to go for assumption: the number of dolls of type A be X and the number of dolls of type B be Y. And here I will go through the conditions one by one and will write the inequalities. The first condition is combined production level should not exceed 1,200 dolls. It is given to you here. Combined production level should not exceed 1,200 dolls per week. Means together X number of A dolls and Y number of type B dolls together, that is X plus Y, should not exceed means should not go more than 1200. That means less than or equal to 1200. First condition we used and we have written the first inequality. Second condition, production level of dolls of type A exceeds 3 times the production of type B by at most 600. So here it is given to you here, the third line, the production level of dolls of type A can exceed 3 times the production of dolls of other type by at most 600 unit. Means production level of dolls of type A, that means X, 3 times the production of type B, that means 3Y, and the difference between these two, X and 3Y, should not exceed, or sorry, by at most 600, by at most 600 in the sense X minus 3Y less than or equal to, at most means maximum 600, so it should be less than or equal to, so X minus 3Y less than or equal to 600. And again the next condition, demand for dolls of type B is at most half of that for dolls of type A. So here it is given to you, type B is at most half of that for dolls of type A. That means Y is less than or equal to X by 2. Demand for dolls of type B, that is Y, is at most means maximum, means less than or equal to half of that for dolls of type A. Half in the sense X by 2, number of dolls of type A, that is X, half in the sense X by 2. Let's rearrange it, this one, we will get it as 2Y minus X less than or equal to 0. So 3 inequalities we have got. Then profit on type A dolls, it is given to you rupees 12, and profit on type B dolls, that is rupees 16. We have to maximize the profit. So maximize Z is equal to 12 into X quantities of type A plus 16 into Y quantities of type B. So Z is equal to 12X plus 16Y. So we have to maximize this one. So we are asked to maximize Z is equal to 12X plus 16Y subject to constraints, X plus Y less than or equal to 1200, X minus 3Y less than or equal to 600, 2Y minus X less than or equal to 0, and finally the common constraints, X greater than or equal to 0, Y greater than or equal to 0. So here this question also you have to draw it on the sheet of graph and find out the bounded region or a region which satisfies all these inequalities, and find out the corner points and substitute here and find out the maximum profit. So let's do it, this one also as homework. Dear students, today we have completed linear programming chapter, and I request all the students to go through all the examples and exercise questions. And if there is any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.